So axiom 1, things are equal to one another if only those things are equal to the same things. So the things are equal to one another if the both equal things are equal to same thing. And second, he says that the wholes are equal if the equals are added to equals. So if the whole thing are equal, if equal is added to equals, Euclid says that. And axiom 3 says that the remainders are always equal if equals are subtracted from equals. So if we subtract equal from equal, the remainder is always we get is equal. The remainder is also will be equal. If we subtract the equals to the equals, then the remainder we get that will be also equal. And things are equal to one another only if they coincide with one another. If the both things coincide with one another, then the things is also we can say equal. Then the whole is always greater than the part. So the whole is always greater than the part, as you know. So some small part, a part is a small part and the whole, the big thing is greater. The whole big thing is greater than the small part that you keep aside, or what you do that is small. Next let's come to Euclid's postulates. Let's come to postulates. So postulates, it is a straight line can be drawn from from any one point to another one. So Euclid's first postulate, we can draw a straight line from one point to any another point. And the first postulate states that at least one straight line passes through two distinct points. So they're showing if there are 2 points, there one straight line should be passed. The Euclid is saying that clearly in the first postulate. If we are taking 2 points and a straight line is passed from both of that, and there should be one distinct line passing from both passing from that, he is telling it clearly. Next is Euclid's postulate 2, that is a terminated line can always be further produced indefinitely. So if a line is drawn between 2 points, it can be increased indefinitely. We can increase it. You can write it as little bit increasing. You can write it as AB. You can write it as big. If see A and B are 2 points, if you draw a line between both the points, and if you increase the point, increase if some point also, if you increase the line, then nothing will happen. He is saying we can increase that indefinitely. The Euclid is saying. So this is Euclid's third postulate. A circle. In third postulate, he says that a circle can be drawn with any center and with any radius. So you can draw a circle with any circle from any center point. You can draw a circle with how much radius you want. You can draw. As you know, you will draw circles at any radius at any point you want. You will draw. So this is the third postulate Euclid says. And its fourth postulate says that all right angles are equal to one another. So he says that all the right angles, whether you take all the right angles, as you know, they are both are equal because they both are equal. They are right angle, this is also right angle. Then right angle is equal to right angle, you know. So they both are equal. The Euclid is saying. Finally, the last postulate is saying that if a straight line that falls on two other straight lines makes interior angles on the same side of the lines taken together less than the right angle, then these two straight lines, if produced indefinitely, they meet on the side on which the sum of the angles is less than two right angles. So if two straight lines are there, it does not become straight angle if it is two straight lines are there. And if we increase that indefinitely, as I said, indefinitely if we increase, we can increase, there's nothing will happen. As I said in the second postulate. Now if we increase also, it does not become right angle. Euclid is saying Euclid is saying that it does not become right angle whether you increase more and more and more and more. How much you want if you increase also, it does not become right angle. The Euclid is saying. Euclid is saying that it does not become right angle. It will become less than two right angles. He is saying, or if you increase, it will become less than one 2 or 3 like that only, it will become less than 2 right angles if you increase also, which would say in the fifth postulate. So this was the postulates, the 5 postulates and 5 axiom of Euclid's. So I think you understand about this. So hello, welcome to my channel and coaching center. So today I'm going to explain your 9th standard maths 5th chapter, and that is and 5th chapter, that is introduction to Euclid's geometry. So introduction of Euclid geometry is our next chapter, and let's come to the exercise. First exercise, that is 5.1, and this chapter has only 2 exercises. So first exercise is, this is the first exercise. So they have given some questions on this. Let's see what is the questions and what we have to write answers. What is the questions? Let's see. Which of the following is true or false? They are asking, and we have to give the reason why it is true or false. True or false. So first question: only a line can pass through a single point. So it is a false. Only one line cannot pass through a single point. There can be many lines. Like if you have a point, you can make more than 7 lines, 8 lines. Like that, how many lines you want, you can pass. Only one line you cannot pass in a point. So the answer is false for this. There are infinite number of lines which pass through two distinct points. So it is true. There is infinity number of lines that can pass through two distinct infinite number of lines that will pass through two distinct points. There are many infinity numbers of lines. So this is true. Next is, it is false, not true, because only one line can pass in that. Not many two distinct lines can pass. In 2 points they are given, only one line can pass through it, not 2 points. No. Next is third one. A terminated line we produced indefinitely on both the sides. Yes. So it is true, because a terminated line can be formed indefinitely on both the sides. It can be passed, or you can pass through the point. You can pass from that point where both the points they have given. So it is true, we can pass this indefinitely, the terminated line we can pass. Next is, if two circles are equal, then the radius are equal. Yes, it is true. See, if a circle of radius a circle has a radius of 2 cm. So if both circles are equal, means another circle will also be having 2 cm radius only. No, how it will be 3? If it is 3 means the radius is, if it is 3 means the size of the circle is not same. So here they are saying that the circle is equal. So both circle are equal means then the radius also equal. If another circle radius is more means then the question they have given will be wrong. So both, so the question they have given is correct and the answer is true. If both the circle are equal, then the radius is also be equal, we can say that. In the given figure, if A, B, P, Q and P, Q, AB is equal to PQ and PQ is equal to XY and AB is equal to XY. So we have to say whether it is true or false. So it is true, AB is equal to XY, because they both are equal, and it is also true that AB is equal to PQ and PQ is also equal to XY, because all are same lines, they are parallel equal lines. So AB is equal to PQ, it is true, and PQ is equal to XY, it is also true. Then AB is equal to XY, it is also true. So this whole thing is true. So this was your second when they have given that, they have asked about the definition of the following terms they have given, that is parallel line. So they have asked us the definition of parallel line. So first they have given the definition of point: a small dot made by a sharp pencil on a sheet that gives an idea about a point. So this is a point as a dimension, it has only a position, the point has only dimension and position. Next is the line they have given. What is line means? A straight trace obtained by folding a paper, a straight string pulled on it at in the two ends, in the middle of both ends. When you elaborate the string, you will get a straight line that they are saying. And plane, as you know, the surface that is smooth surface is called as plane. And a ray, a part of plane in which I which has only one end point A and contains the point B is called as ray AB. AB ray we call, angle. So angle is the union of two non-collinear rays which commonly integral of points. So two non-collinear means it does not have a length. We cannot explain it first. So next is circle. So this is the circle, like this it has radius, and the square. A square is a quadrant having the all sides of equal length. So square has all sides of equal length and equal measure we will get. And there are known as quadrilateral, side and angle, different types of square we call. So next third question or third sum they have given is consider the two postulates given. So they are asking the first question, that is, give any two distinct points A and B. There exists third point C which is between A and B. So we have to say whether it is correct or not. So it is various undefined points, because say if you have two line A and B, in the middle you will write C, then how it will be correct? So they are not undefined points there, it is not correct. And his postulate consists because they refer to different solutions. They have two different solutions in that. Next they are asking that there exist a least 3 points that are not on the same plane. So it is also impossible to deduce, and any statement is contracted any well-known axioms and postulates. So does postulate contains any undefined terms? There are many undefined terms in these postulates, and these postulates consist of, because of two different situations they are consist, and these consist to so these postulates do not follow the Euclid's postulates. You may know Euclid's postulates, you may have learned in your 8th class, and they follow the axiom given in the distinct point, the unique. So they will follow the axiom postulates rule. Next is fourth question, that is, if a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to 1 by 2 AB. We have to prove that. So like this one, put a line there, AB in the middle of that, C will get. So they are asking that AC is equal to AB, and we have to prove that AC is equal to 1 by 2 AB. So now let's consider as AC is equal to BC, and now let's take as AC plus AC is equal to BC plus AC, that we get 2AC is equal to BC plus AC we get. And next we have, let's shift that, therefore we get BC plus AC is equal to AB we get. If you do square we get AB. Next is, let's take AC plus AC is equal to AB. So 2AC is equal to AB. When we calculate, we get 1 by 2 AB. AC is equal to 1 by 2 AB, we get the answer. So next question they have given that in the above question, point C is called as midpoint of line segment AB. Prove that every line segment has one and only one midpoint. So it has only one midpoint and only one line segment. So they have given figure AB, in that the middle is 2 points, that is C and D, and let there be midpoint C and D. They both are midpoint, and C is midpoint of AB. Let's take a C as midpoint of AB. Next is let's prove that for every line segment has one and only one midpoint it has. So let's prove that. Let us assume that D is another midpoint of AB. Let us take AD is equal to AB. Let us take AD is equal to AB then. But it is given that C is the midpoint of AB they have given. So therefore AC is equal to CB. Let's take like that, and let's put both the equation. So when we put both the equation, we get DC is equal to O. Like that only lengthy solution where it is very long. Next is AC is equal to CB we will take, and AC plus AC is equal to BC plus AC. We get BC plus AC is equal to AB, and AC plus AC is equal to AB we get when we put like that. 2AC is equal to AB, and also when we put the second equation we get 2AB by 2AD by AB also we get. And also when we calculate when we put both the solution in the one page or one line, so they are like that we have to solve this. And as you know, this is the possible only when the point C and D are represented in a single point, hence our assumption is wrong, and there is only there can be only one midpoint. So there can be only one midpoint, and what we assume that there may be two midpoints for that our assumption became wrong. Let's take the final two questions of this 5.1 exercise, that is, in the following figure, if AC is equal to BD, and then prove that AB is equal to CD. So we have to prove that. Here they have given a figure that in a line they have get AD, and to two midpoints they have given B and C. In that we have to say that AC is equal to BD, they have said that, and now we have to prove that AB is also equal to CD. So let's take AC is equal to BD, AB plus BC let's take, and next BD is equal to BC plus CD let's take. BC plus CD let's take as, and they have given that AC is equal to BD in the question they have given, and we have to prove that AB is equal to CD. Let's take the proof. So let's put both of solution that is taken from the figure we got, that is AC is equal to AB plus BC and BD is equal to BC plus CD. Let's put that, and when we solve that we get AB is equal to CD. When we solve that, when we put that and when we solve, we get AB is equal to CD, that was given in the question, and hence we proved that we have to write. Next is, which is axiom 5 in the Euclid axiom, which is universal truth. So axiom 5 states that the whole is greater than the part. The whole is greater than the path. And then the one part, if in a circle they have given the part, and in another side if they have given the whole circle, then the whole circle is greater than the one part they have given for us, and the axiom with the notes the universal truth because it holds true in any fields, and not just in the field of maths only. So not in just in the field of maths only it is true, we can say. It is true, it is true, we can say. In many fields it is true, we can say. So it is true, we can say. In many fields we can say it is true. Yes, it is true, we can say. And also case 1, let T represent a whole quantity and only A, B, C or parts of it. T is equal to A plus B plus C. Clearly T will be greater than all its parts A, B and C. Therefore it is rightly said that the whole is greater than the part. We can say that whole is greater than the part. Let us consider the continent of Asia. Let us consider a country India, and India which belong country India. Let us consider our India that belongs to which continents. Next, India is a part of Asian continent, as you know. That is why we can say that the whole is greater than the part, because in whole Asian continents, India is a small part, we can say part, and the whole continents of Asia we can say it as whole. As I said in the first, we can say it as the whole Asian continent, we can say, and it is greater also, we can say that. Next is exercise 5.2. So this is exercise 5.2. So let's come to exercise 5.2. First question: how would you rewrite Euclid's fifth postulate so that it would be easier to understand? So how to rewrite Euclid's fifth postulate so it would be easy to read it for you or read it for you, they are asking. So 1 minute. Now let's continue. So let's come to that. So easier solution, we can say there is a line through P which is parallel to I. Easily we can say, if you want to say it easily means we can say like that, and there is only one such line like that we can say. So line solution, two lines are said to be parallel if they equidistant from one another, the equidistant length from one another, and they do not have any point of intersection. The equal distance should be there, and there should be no intersection between that point. Then we can say it as Euclid's postulate, and also we can say it as, and also next is, in order to understand it easily, let us take a line I and O and a point P not on I. So let us take a point as I and a P. Here they have given one line on, and carefully, and we should not take the I. We should not take I in the point of P. On the point of P, we should not take it. Take I. I we should write separately, and P we should write separately. Separately, they are saying us. Next, then the Playfair axiom is unique line M through P which is parallel to I. We can say, next we can also say the distance of the point from the line is the length of the perpendicular from the point to the line. The distance is perpendicular to the point to the line, we can say, and let AB be the distance of any 2 points. Let's take as AB as any distance of 2 points from M to I. From M to I, we can say that is a distance A to B, and CD is a distance from point from I to M. Like this, you should take AB as the point from M to I, and CD as the point from I to M. Like that, we shall take. So AB is the distance of point from M to I, and like that if we take, so it can be considered that next. Let's take next, as they have given AB is equal to CD only now. So they have given, so therefore the two lines are everywhere equidistant from one another. So they are equal, we can say like that only. We can explain the Euclid's postulate. So second question is that, does Euclid's fifth postulate imply the existence of parallel lines? Explain. We have to explain that Euclid's fifth postulate is parallel or not. So there we can say easily that if a straight line I falls on two straight line M and N such that the sum of the interior angles on one side of I is two right angle, and then the Euclid's fifth postulate is postulate the lines will not meet at these sides of I. We can say, let's see, we can say like this. Next we know that the sum of the interior angles on the other side of line I will be also be the two right angles, therefore they will not meet on other sides also, so therefore they should not meet. So the lines M and N never meet and or therefore parallel. So the line M and N are therefore parallel. Like this we can draw and we can explain it. So